Hello, my name is Will Armijo, and I'm from Atmospheric and Space Technology Research Associates, or ASTRA. The Navy has asked our company to develop a novel smallsat payload that drastically reduces the size, weight, and power, or SWaP, of sensors that have traditionally performed naval weather sensing missions. We developed a sensor called CO2, CubeSat Ocean Observing Sensor. This sensor can measure both the speed and direction of winds on the surface of the ocean. It is a very low SWaP package with a high level of manufacturability, which ultimately leads to an increase in the quantity of sensors in flight and reduced revisit time. Both of these features enhance the Navy's nowcasting and forecasting capability. This technology specifically addresses the gap in the current on-orbit assets, as well as the availability for critical ocean surface vector wind measurements over the next several years. The need for high-resolution ocean surface vector wind measurements are critical to the commercial maritime sector as well. I challenge you all as my fellow peers to think of an application in which knowledge of the state of the wind on the sea can be valuable and life-saving data points. If the sensor that we have developed and are flying in late 2021 interests you, please contact me so we can discuss how our solution can help solve your problems. ASTRA is celebrating its 16th year in business, and we continue to show, year after year, that a small, agile company can develop beyond state-of-the-art instruments in the most efficient manner possible, enhancing our community's scientific knowledge, as well as the United States' presence in space. Our success in the SBIR community boasts a 40% conversion rate of programs moving past Phase 1. In fact, the primary subsystems of the CO2 sensor in this presentation are technologies resulting from previous SBIR success stories. Our team has grown significantly over the past several years, with over 90 staff scientists and engineers tackling some of today's biggest problems. Located in Boulder County, Colorado, we are strategically located in the heart of one of the largest aerospace communities in the United States. From mission concept, through development, assembly, integration, test, and running mission operations for on-orbit assets, ASTRA is able to offer complete end-to-end mission solutions for our customers. Come find me exhibiting at this conference and let's chat. If you weren't able to attend this week, send me an email. I'd love to hear from you. The challenge presented to us for this project was to develop a very small SWaP sensor that could be manufactured at scale to close the gap in weather forecasting in naval theaters of operation. The SWaP of this first flight article, which is enclosed in a custom machine enclosure rather than a CubeSat, is 2.6 kilograms, consuming 8 watts on orbit. This SWaP will be further reduced when integrated into a cube or other small sat. ASTRA's many years of experience developing sensors and integrated small satellites led to a successful Phase 1 and Phase 2 for this program, with the result of this Phase 2 being a fully functional flight article that will launch for space operations in late 2021. Traditionally, large and costly sensors were required to measure ocean surface vector winds. Moving to this low SWaP sensor will reduce costs significantly and allow for a constellation of sensors to be flown. Compare this revisit capability with WinSat and other monolithic satellites of the past. Even other current commercial offerings in this domain are around 2 times larger and can only measure the speed or direction of wind on the surface of the ocean. As stated, the CO2 sensor leverages subsystems that are products of heritage ASTRA SBIRs. These subsystems that have previously been commercialized were modified, validated, and tested for spaceflight and this particular CO2 application. These major subsystems include our high TRL ASTRA proprietary GPS receivers, power distribution system, and low noise amplifiers. All other major subsystems for this sensor were designed and fabricated by ASTRA with standard hardware and connectors purchased as COTS or commercial off-the-shelf. The CO2 program is still in its Phase 2 of the STTR, and at the beginning of 2021, ASTRA delivered the flight hardware article to the flight sponsor with a planned launch for Q4 2021. For the remainder of this phase, ASTRA is preparing the on-orbit operations and data processing for delivery to the Navy customer. All operations and data processing will occur at the ASTRA facility in Boulder County, Colorado. To summarize the Navy challenge, the ASTRA CO2 sensor has exceeded the expectations of this STTR and assembled, integrated, and tested a spaceflight article all during this Phase 2. ASTRA controls the design, fabrication, and test of all major subsystems, and is capable of producing CO2 sensors in quantity for future customers. Our Mission Operations Center is configured to perform the commanding and mission operations as well. Enabling the Navy and other DoD entities to fly a low-swap constellation of weather monitoring sensors will change the paradigm of how rapidly we can advance United States' presence in space and improve knowledge of our ever-changing global conditions. Beyond Phase 2, ASTRA plans to produce additional CO2 sensors for flight on customer spacecraft. Our customer in this case refers to our DoD customers that have a need for weather nowcasting and forecasting capability in a very low swap package. Our primary advocate is our Navy customer and their Space Force partners that have a need to rapidly improve sea state weather knowledge. Following our flight this coming November, we will validate our design and be ready for full-scale production. Because the CO2 sensor measures both the speed and direction of the wind on the surface of the ocean, there are many other real-world applications for this data. The maritime shipping industry, offshore oil installations, disaster preparedness organizations, and other ocean research entities can all find applicability and usefulness from high-resolution ocean surface vector wind data. If you think of anything that's not covered on this chart, please come find me. I'd love to hear your ideas. ASTRA's desire is to make our technology and this sensor available for your applications. I would love to talk to any of you that are interested in this sensor, any applications that you might have developed while watching this Tech Talk, or any of our other solutions that we can provide to you, our partners. Thank you all again for your time today. I am here at Sea, Air, and Space, and I hope to chat with you about what ASTRA can do for you.